Hi, so today we're going to be solving some problems using vector identities. So the first one is if we are given the dot product of A and B is equal to rad 3 and the cross product of A and B is equal to the vector 1, 2, 2, what is the angle between A and B? So we can do this using our vector identities where the dot product of A and B is equal to the magnitude of A times the magnitude of B, cosine of theta, and the cross product of A and B is equal to the magnitude of A and the magnitude of B times sine theta. So solving for cosine theta, we get the dot product of A and B divided by the magnitude of A times the magnitude of B, and solving for sine of theta, we get the cross product of A and B over the magnitude of A times the magnitude of B. And going over here, we can cancel out the denominators by dividing sine by cosine, and we'll get A cross B over A dot, the dot product of A and B. And sine of theta divided by cosine of theta is equal to tangent of theta. I have that identity here. And so to find theta, we can take the tan inverse of the equation we just found, the cross product of A and B over the dot product of A and B. So we get theta equals the tan inverse of the vector, the cross product vector, which is 1, 2, 2, over the dot product, which is rad 3, which is given to us. So we can find theta is equal to 30 degrees, 49 degrees, and 49 degrees by plugging it into our calculator. And then for a second problem, we are just going to do a proof where we show that the cross product of the magnitude of A and B squared is equal to the magnitude of A squared and the magnitude of B squared minus the dot product of A and B squared. So if we write out the formulas that we used here with cosine of theta and the sine theta, those identity formulas, we get the magnitude of A squared times the magnitude of B squared times sine squared of theta plus the magnitude of A squared times the magnitude of B squared times cosine squared of theta equal to, minus the dot product, the magnitude of A squared times the magnitude of B squared times cosine squared of theta. So we can add this whole term over here, just using algebra, and that is the line you'll get. We just move this term over here. And then if you factor out the magnitude of A squared and the magnitude of B squared, you just get sine squared plus cosine squared of theta, which is equal to 1 because of the trig identity. Sine squared of theta plus cosine squared of theta is equal to 1. And since that's just that multiplied by 1, you just get the magnitude of A squared times the magnitude of B squared, which is already on the right side of our equation after we added this term over here. So that's just our proof because those two are equal to each other.